Hello, this is a video for explaining some homework. This is for Math 2-3. This is the homework from page 269, number 1. That's the steel roller coaster problem. And this is the explanation. The problem asks us to look at some information about steel roller coasters from theme parks in the United States. And we use some survey data from 1999 and then again in 2006 to find out how customers who rode the rides ranked those rides. Here's a graph that is a scatter plot of those rankings, and we're wondering why might those ranks change from year to year, because the roller coasters don't change. There's lots of good reasons. Different people were surveyed in 1999 and in 2006, and different people have different preferences. Also, it's unlikely that very many people have ridden all 10 roller coasters, so each person in the survey should have been asked to rate only those that they have ridden. So to get down to the math of this, there's a couple of things that we've used to analyze these scatter plots. The question is the relationship positive or negative? To figure that out, we need to estimate a line of regression. So I am going to draw what I think is the best fit line. Looks pretty good to me, and that is definitely positive. So the relationship is positive. Is it strong or weak? Well, that's a little harder to tell. Let's use the trick with drawing an oval around all the points. And that oval is not very skinny. I can see that there's definitely an upward trend, and the best fit line seems to fit pretty well, but the strength of this correlation, I'm going to say, is neither strong nor weak. I think it's kind of right in the middle. My estimate for right in the middle, I'm going to call this a 0.6. Now, it's entirely possible that you estimated that it was a little bit stronger. Maybe you thought it was a 0.7, or you thought it was a lot weaker, like a 0.3 or a 0.4. Estimates on these things can vary, but we're trying to learn how to guess or estimate it first, make an educated guess, before we spend a lot of time doing the math to figure these things out. But since we're here, let's do the math to figure these things out. I want to point out that this is the chart from the original page, but I have extended the chart so that we can use some clever tricks so that we don't have to just plug a bunch of numbers into a formula. That can be really confusing. Here, we're going to need to know how many of these roller coasters are being ranked, and there are 10 of them if you count them up, and that was said in the original problem too. So that means that the value of n for number is going to be a 10. So I'm going to use this to put in some numbers. Also to point out that the sum of the differences, I've already put in the differences. The difference between 1 and 1, of course, is 0, and the difference between 10 and 3 is 7. Sometimes they're negative. 5 minus 8 is negative 3. I've already put those in. But what we need to do is square each of those. 0 squared is easy. Negative 2 times negative 2. Remember that these, when you square a negative, it's always a positive. So I'm just taking the square of each of these numbers. And this one's big. And then I'm going to total up this column, the d squareds. That's what this symbol right here means, the sum of the d squareds. and that turns out to be 80. Now I need to plug these numbers that I just got, the sum of the d squared and n, into the formula for Spearman's rank correlation, which is right here. Using this formula, which we're going to break down into pieces, we can find out R, the strength of the correlation, and this is R sub S, because this is R, the rank correlation for Spearman's formula. So I'm going to plug in the numbers. I've already started here. I've got 6 times 80, because the sum of the d squareds from the last page came out to be 80. And n is 10. And then a little bit in my head here. If n is 10, then n squared is 100. And 100 minus 1 is 99. So this equals 1 minus, let's see, 6 times 80, that's 480, over 10 times 99, of course, is 990. And then you would use a calculator to simplify this. Put in 1 minus, parentheses, 480 divided by 990, close parentheses, and you'll see that this works out to be 0.515, which I'm going to round off to be 0.5. So my estimate from when I looked at the scatter plot was pretty close. I said it looked like about a 0.6. The actual number came out to just over 0.5. So this is definitely a moderate strength correlation in the positive direction. Notice that this 0.5 is a positive 5. If the correlation was negative, we would see that it was a negative number. But this one's positive. And that is problem number 1.